Okay, so I'll be talking about balancing chemical equations and using mole ratios to predict amounts needed or produced in a chemical reaction. So the reason that we balance chemical equations is because of the law of conservation of mass, which is that energy cannot be destroyed or created, only transformed, which means that we have to have the same amount of elements on the reactant side as well. Okay, so in this sample problem, we have H2O makes H2 plus O2. So on this side of the equation, we have two H's, H2, and we have one O. And on this side, we have two H's and two O's. Now that's not even, is it? The H's and the O's on each side, we need to have the exact same amount. So we're just going to add another H to a 2O over here. So that would give us 4 H's, because 2 times 2 is 4, and 2 O's. So now we have 4 H's and 2 O's, 2 H's and 2 O's. So we need 2 more H's on this side. So we're going to put a 2 in front of the H2. So now we have 4 H's and 2 O's, and 4 H's and 2 O's. So we have a few sample problems here. So in the first one, we have Fe plus Cl2 yields FeCl3. So on this side, we have 1 Fe, we have 2 Cl's, and on this side we have 1 Fe and 3 Cl's. So we want to balance our Cl's. So on this side we're going to put 2 Cl's, so this will have 4 Cl's. But that still doesn't add up. That doesn't add up to a multiple of 3. So we're going to put 3 Cl's. So now we have 6 Cl's on this side. And if we put a 2 here, we have 6 Cl's on that side. But now since we put the 2 here, we have 2 F's. So we have to put a 2 in front of the F. So now we have 2 Fe plus 3 Cl2 yields 2 FeCl3. In our second equation, we have CH4 plus O2 yields CO2 plus H2O. So on this side we have 1 C and 4 H's and 2 O's. And on this side we have 1 C, 2 O's, 2 H's, and another O. So on this side we have a total of 3 O's, and on this side we have a total of 2 O's. So if we add a second H2O, that means we would have 2 O's, and we would add 2 more H's and 4 H's. So now we have 4 O's on this side, and if we put a 2 in front of the O2, we would get 2 more, so we would have 4 O's. So now we have 1 C, 4 H's, and 4 O's on each side. Okay. In the last equation, we have KMnO4 plus HCO yields KCl plus MnCl2 plus H2O plus Cl2. So on this side, we have 1 K, 1 Mn, 4 O's, 1 H, and 1 Cl. And on this side, we have 1 K, 1 Mn, 1, 2, 3, 4, 5 Cl's, 2 H's, and 1 O. So we know we need 4 O's on this side, so we're going to add a 4 in front of there. So now we have 4 times 2, which is 8. H's and 4 O's. So now that we added our 8 H's over here, we need 8 H's over here. But we also now need 8 Cl's. Also on this side, we need 8 Cl's over here. So we're going to put a 2 in front of the Cl2 to give us 4 more Cl's. So now we have 1K, 1K, 1 Mn, 1 Mn, 4 O's, 8 H's, and 8 Cl's on each side. So now that we've balanced our chemical equations, we are going to do a limiting reactant problem with the balanced equation. So we're given C6H12O6 plus 6H2O yields 6CO2 plus 6H2O. And we're given 25 grams of C6H12O6 and 40 grams of O2. So we're going to start with our 25 grams of C6H12O6. And we're going to make a T-chart, so we're going to divide that by the mass in the periodic table, which is 180 grams, 180.6 grams, which equals 1 mole. So our 25 grams is 1.388 moles of C6H12O6. And then our 40 grams, O2, divide that by the mass on the periodic table, which is 32 grams. And that equals 1 mole. So we are given 1.25 moles of O2. So now we're going to convert each of these moles to one of our reactants. So I'm going to pick CO2. I'm going to take my 1.388 grams of C6H12O6. And, wait, no, that's moles. And we're going to do a mole ratio with our balanced equation. So in our balanced equation, we have 1 mole of C6H12, which equals 6 moles of CO2. So, if we take that, so we're going to take 1.388 times 6 and divide it by 1. So we are getting 8.33 moles of CO2. Now we're going to do the same thing with our O2. We're given 1.25 moles of O2. And we're going to use our mole ratio, so we're given 6 moles of O2 for every 6 moles CO2. So if we times 1.25 times 6 and divide it by 6, we're going to get 1.25 moles CO2. So in order to determine which one is your limiting reactant, you need to determine which one produces the least moles of products, which would be our 1.25 moles, because that's less than 8.33. So our limiting reactant is